how do I go ahead and retrieve the last message? It is nothing but response of message minus one. Okay, so here you can see that I have got this. And if you just go ahead and write dot content, you should be able to get, hi, it's nice to meet you. Is there something I can help you with? Okay. So this is the most easiest way of probably reading all this stuff. Okay. Now, there are two more ways of streaming it, right? Streaming your specific data or running your entire graph and displaying the information, right? So that is what we will discuss now. And understand one thing, guys. If you are able to understand this, right, trust me, as you go ahead, any kind of graph, any kind of complex workflow that you have in your mind, you should be able to execute it. Okay. Now, what I will do, I will go ahead and write for event in graph.stream. Okay. So this time, instead of directly using graph.invoke, I am using something called as graph.stream. We will understand about this as we go ahead, but I just want to give you some kind of information how things work in this. So now here I will give you messages. Okay. And colon, let's say here I go ahead and give hi. How are you? Okay. So this is what is my message. Let's see whether everything looks fine. Yeah, this is my for loop. Yeah. Now what I'm actually going to do, I'll just go ahead and write print event. Okay. Now let's execute this. So here you can see that inside this, I have got an output which looks something like this. AI messages, AI message, all this information, and I'm getting this, right? Now, when I am doing graph.stream with this particular input, right? So here I'm getting with LLM chat. LLM chat is nothing but my node which you are able to see this. Okay. Now let's say that I will go ahead and write one more for loop. I'll write for event, also for value in event.values. Event.values. Now what will happen if I just go ahead and print this? Okay. See, I'll print my value. Now, if I execute this, here you can see that I'm getting this AI message, right? So that basically means now, whenever we try to stream from this graph.stream and whenever we try to see the event values, only AI messages will be getting displayed, right? Now, in order to display this, what I can basically do is that I can also go ahead and write value of messages, which will be my last message minus one. And here I'll just use dot content, and this will basically display the same thing like what it was displayed over here, right? I am just language model, so I don't have feelings or like human do and all. This is just one specific example I've told about streaming, but don't worry. Because this streaming, we will discuss more about it. There are multiple types of streaming. With respect to streaming, you can also provide different parameters, what exactly it means, so we will discuss about it as we go ahead. But here, this was just an example of how you can go ahead and build a basic chatbot. Okay. Now it's time that we start thinking, Krish, can we go ahead and integrate some kind of external tools? Okay. So for this, let me go ahead and talk about a use case. Let's say I have a So for this, let me go ahead and talk about a use case. Now it's time that we start thinking, Krish, can we go ahead and integrate some kind of external tools? Okay. So for this, let me go ahead and talk about a use case. Let's say I have a chatbot. Okay. Now this chatbot, I have a question. I can basically go ahead and ask a question for this chatbot, saying that, hey, let's say this chatbot I have. And this chatbot, what does it have? It basically has a LLM with some kind of prompt, and it is taking an input from the start, and it is basically ending it, right? So here, start, end. Now, if I ask a question, provide me the recent AI news. Do you think this chatbot, with the help of this LLM, will be able to provide the output? The answer is simple, no. It is not able to provide it. Why? Because LLM will not have any information related to life. Provide, end. Now, if I ask a question, provide me the recent AI news. Do you think this chatbot, with the help of this LLM, will be able to provide the output? The answer is simple, no. It is not able to provide it. Why? Because LLM will not have any information related to life, right? Any live information it will not have. It may have not trained with the recent data, right? So here, the dependency on external tool comes, right? External tools comes, right? So what we can basically do is that for this chatbot, as soon as we give an input, the chatbot should understand, hey, we are not able to answer it, so I definitely have to make a tool call. And when I'm making a specific tool call, this tool call, let's say this can be any third-party API, it can be Google search engine, it can be, let's say one of the search engine that we're going to use is Tably. Tably is nothing but it is a web search. It provides a web search API. Okay. And with respect to this Tably, we will be able to get some kind of response over here. Okay. So as soon as we make a tool call, or in order to define it like this, I'll just make this graph a little bit longer now. Okay. So what happens as soon as I get an input? The next thing is that the chatbot is understanding it is a tool call. So it goes and makes a tool call. And here we will define another node, which will be called as tool node. Okay. And then based on this tool call, I should be able to get the response in the end. Okay. So instead of chatbot not able to give you the output, let's say if I give any input, provide me the recent AI news, this request will go to the chatbot. Chatbot will understand, hey, we do not have that information, so definitely I have to make a tool call. So here what it will do, it will make a tool call, and then from here it will go to end. Okay, it will go to end, right? And here in this tool node, I may have multiple tools. I may have tools like Tably. I may also go ahead and define some custom tools. Let's say add, subtract, or some custom implementation also you can go ahead and write. Right? Now the question arises, how does this chatbot knows about the tool node? See, there is something called as LLM. Okay, inside this chatbot we use LLM, right? LLM is actually the brain behind taking this decision. Why? This LLM can be binded with these tools. When LLM is binding with these tools, what does this basically mean? Here it means that, let's say I go ahead and create one custom function. This custom function is called as addition. Let's say this is my addition. This can be added as a tool to the LLM. It can be binded with LLM itself. Then the LLM, here whenever you define any custom tool, you also need to provide the docstring. Now with the help of this docstring, the LLM will know what are the inputs and what are the arguments that is required over here. So if this inputs and arguments matches with the input that we are giving in this chatbot, then automatically this is going to make that particular tool call, right? So this same thing I will try to show you in the practical way. We will go ahead and create some tools. We'll also go ahead and create out some of the custom tools. And once we do that, what we're basically going to do is that we're also going to go ahead and create tool node. And there is one more additional condition, which is called as tool condition. So we will discuss about all these things with respect to this particular implementation. But our main point over here is that the chatbots can also be integrated with a separate tool node, and here it can also make a tool call based on a specific input that we get. Okay, how that can be implemented? By binding tools with the LLM and also defining your custom functions if it is required. And this LLM will be able to understand whether it has any tool or not through these doc strings. Okay, so now let's go ahead and implement those functionality. So guys, now let's go ahead and start building a chatbot with tools with the help of LangGraph. Now first of all, I'll just show you like what we are trying to build over here. Okay, so here is one graph, which we will try to create. Now just observe this graph. Okay, this graph is quite amazing because here we have a separate set of tools. Okay, here we have a tool calling LLM. Okay, so from here we are definitely going to give our input. Now from this input, as you know, these are my edges. This tool calling LLM is my first node, and this node has LLM with binding tools. Okay, when I say binding tools, what does this basically mean? So this means that I have LLMs and tools integrated with themselves. We will use a couple of tools. One of the most famous tool that we will try to use, let's say we will use Tably API or Tably search. This is just like an internet search. Along with this, we'll also create some of our custom functions. Okay, we will create some of the custom functions or custom tools. Okay, tools. And remember here, when I can also combine multiple tools in one tool node. Okay, so here what you're doing is that we're going to combine this in one tool node. Okay, so this is nothing but this is a tool node. And here you can observe one more very amazing thing, right? So from this particular tool, from this particular node, here we have two paths. Either we can go there, here, or either we can go over here. So let's say if my question is, hey, what is the recent AI news? So the input will go over here. Then this tool calling LLM will decide whether it can give the answer or whether it is dependent on some tools. Since we have binded these tools, and remember how LLM will be able to understand from the doc string, right? So in every tool, there is some kind of doc string. Doc string is nothing but some brief information about what that tool actually does. Okay, I will also define one custom and show it to you. Then this tool calling LLM, since it has those tool information, it will take a decision whether it can just answer it and go to end. Let's say if it makes a tool call, the tool will then provide some kind of output message and it will end. If it is not a tool call, it is just going to go and give you the output and go to the end state. Okay. Things that we are going to solve right now. Okay. The fundamentally simple problem things that we are going to solve right now. Okay. And we'll solve it step by step. Okay. How do we go ahead and solve it? That I will discuss as we go ahead. Okay. So now let me go back to my code. So first of all, in my requirement.txt, I will go ahead and import one library which is called as langchain_tably. Okay. Now langchain_tably is nothing but if you see in my .env right now, I don't have a Tably API. We need a Tably API. Okay. And in my requirement.txt, we need to first of all install this. So quickly, let's go ahead and open my terminal. And here I will go ahead and write uv add -r requirement.txt. Okay. So once we do the installation will be completed, and we are good. We have this langchain tably. The next step will be that I will just go ahead and open this website we call as Tably. Okay, so here you can just go ahead and search for tably.com. You have to restart your kernel, otherwise things will not work. The reason is very simple because we need to import this again. So I will first of all go ahead and execute this. This will basically be my LLM. Okay, this can be LLM, no worries. Okay, now I'll go back over here. Now let me go ahead and import some of the libraries. Right, so for Tably, first of all I'll go ahead and import this tool. So I'll write from langchain_tably. Okay, I'm going to go ahead and import Tably search. Okay, I will go ahead and create this tool wherein I initialize the Tably search, and here my max_results is equal to 2. Okay, and then I will define my tools. Let's say this will be my list of tools. Okay, I can still define many number of tools I like. Okay, but I'll use this tool. Let's say I will go ahead and just invoke with one message. Let's say I will write what is LangGraph. Okay, so this will basically be my question. Now once I execute this, here you should be able to see some kind of response. So here you can see what is LangGraph results. You are able to see all these values, title from different source and URL. You are able to see this, right? LangGraph is a Python library, and all this information is specifically coming out. So once we have created this Tably search tool, now our next step will be that we will just go ahead and try to create our custom method. Okay, custom function. Function. So that gives you an idea like how you can also integrate a custom function and how LLM is able to understand, because I spoke about something called as docstring, right? So how do we write this docstring? Everything we'll discuss, right? So let's take a basic function. So here I will define one custom function, and this custom function here we're going to just go ahead and write definition multiply, and let's say here I will go ahead and write a int b colon int, and let's say this is going to return type of int, right? So now the question is how do we go ahead and write our document string? So this basically gives you a document string example. Okay, here in the summary, let's say I will go ahead and write multiply a and b. Okay, and then here let's say a will be my first int, b will be my second int, and it returns an output int, right? And I type of int, right? Definition multiply, and let's say here I will go ahead and write a int b colon int, and let's say this is going to return type of int, right? So now the question arises, how do we go ahead and write our document string? So this basically gives you a document string example. Okay, here in the summary, let's say I will go ahead and write multiply a and b. Okay, and then here, right, gives your now the question arises, how do we go ahead and write our document string? So this basically gives you a document string example. Okay, here in the summary, let's say I will go ahead and write multiply a and b. Okay, and then here let's say a will be right. So now the question arises, how do we go ahead and write our document string. So this basically gives you a document string example. Okay, here in the summary, let's say I will go ahead and write multiply a and b. Okay, and then here let's say a will be my first int, b will be my second int, and it returns an output int, right? So it is something like this. I've just written some information. Now this is what is called as docstring. Okay, now this docstring will be very important because once we bind any functions, right, with our LLM, or these functions can also be converted as a tools and bind it, right? And then LLM will be able to understand what this tool will be able to do it. Now what I will do, I will go ahead and create my variable tools. Here I'm going to use first tool, comma, multiply, and let me just go ahead and execute it, right? Now as I told you that I need to bind this entire tools, this list of tools with my LLM. So I will go ahead and write LLM dot bind underscore tools, and here we're going to basically go ahead and write tools, and this will be nothing but LLM with tools. So once I go ahead and write, so here now, if you go ahead and see, this is nothing but LLM with tool, right? So this is nothing but it is a runnable binding chat grok. It has all the information over here, and what all functions it is basically connected to. Like it is connected to tably search, it's connected to multiply. You can find out all those specific information over here itself, right? And this is how things work in this. Now once we have defined this LLM with tool, this tool we are going to use inside our chatbot node. Okay, so now let's go ahead and create the entire state graph. Right. Remember the structure of the state graph, how it will be. I have start, I have tool calling LLM, this is connected to tools, and this is end. Okay. Now our question is that how do we basically create this tool nodes also? And for this also we have some predefined packages available in LangGraph. Okay. So I will quickly go ahead and write from LangGraph.graph. As usual, I'm going to go ahead and import state graph. See, again, I'm importing all these things so that you get to know, like, I know in the top already we have imported it, but you should know what all things are there. So from LangGraph.prebuild, I'm going to go ahead and import tool node, right? See, we have anyhow binded this LLM with all these specific tools, right? So binding will play a very important role. See, there are two important things. One is binding. When we are binding LLM with tools, this actually helps the LLM to understand which all tools it has, right? So whenever an input comes, it's just like, just imagine LLM has some kind of weapons to solve your input, right? If I ask, hey, provide me the recent AI news, obviously LLM will not be able to do it. It will do an internet search and it will try to provide you the response, right? When we do this binding, it is just trying to give you an information that LLM has all these specific tools. But further, when an LLM makes a tool call, it has to make a call to this tool. That is what we really need to understand how that tool call will be happening. Okay. So I'll go back over here. We have imported something called as tool node. Now all the tools that we have created, these all tools, it has some kind of functionalities, right? These needs to get converted into a tool node, okay? Because each tool node will be having some kind of implementation. Along with this, we will also go ahead and import one more library from LangGraph.prebuild, import tools condition, okay? Now, first of all, we will go ahead and start with the node definition, okay? Here we are going to create a definition, okay? And before creating a node definition, first let's start creating the graph, okay? So first of all, we're going to use a builder. This will be of type state graph. And inside the state graph, we will be using something called as state, okay? This will be our class, specifically state class. Then the next step is that we're going to go ahead and create our builder.add node. So two nodes we definitely require. If you see in this graph, one is the tool calling LLM and one is the tools, right? So first we will go ahead and create this node. Inside this node, we will give the name as tool calling LLM, okay, comma, and then I have something called as tool. I have to define the functionality of this node, right? So this in the later stages will define. Still, I'm not defined because I will be defining it over here. The other edge that we really need to create, this node, we will give the name as tool calling LLM, okay, comma, and then I have something called as tool. I have to define the functionality of this node, right? So this in the later stages will define. Still, I'm not defined because I will be defining it over here. The other edge that we really need to create, or other node that we need to create, is nothing but add node. Is nothing but tools. And remember, this tools will be nothing but will be of node type of tool. And here we are going to give all our tools itself. So this node is nothing but it is this specific nodes. And inside this node, if I want to go ahead and write a definition, it will be of tool nodes. If you go ahead and see the definition of this tool nodes, it is how all the list of tools that we specify, it will be implemented as a tool node itself. Okay. So this is my node name and this is the definition. This is my node name and this is the definition. Now let's go ahead and create a definition. So for creating a definition, I'll go ahead and write tool definition. Now let's go ahead. This is my node name and this is the definition. This is my node name and this is the definition. Now let's go ahead and create a definition. So for creating the definition, I'll go ahead and write tool underscore calling underscore LLM. And here we're going to define state, colon state. And here we're going to go ahead and write return messages, colon. Again, what we're going to go ahead and write here, we're not directly going to call LLM, but instead we're going to call LLM with tool, right? So here LLM with tool dot invoke. And where do we get the input from? From state of messages, right? So here we're going to go ahead and define state of messages. Perfect. So here you can see very clear. Now in the next step, we are going to go ahead and add the edges. Now adding the edges is really important. If you understand this, any kind of complex use cases, you'll be able to understand it. Okay. So the first edge is from start to tool calling LLM. Okay. So first of all, let's create that. In order to create it, we will just go ahead and write something like this. See, builder.add edge start to tool calling LLM. Now from tool calling LLM, there are two nodes that are going on, right? Sorry, two edges. One edge is going to the end and one edge is going to the tools, right? Now this kind of edges are called as conditional edges. Okay. So in order to add conditional edges, it will be like builder.add conditional edges. And inside this, we are going to call our tool calling LLM. From tool calling LLM, this will happen, right? From this specific node, it is going to happen. So tool calling LLM, and in the next, this is really important, okay? In the next, we are going to import something called as tool condition. Now the question arises, Krish, what is this tool condition? Tool condition applies two different kinds of conditions. One is, let me go ahead and write it over here. If the latest message, right? in the input message when we're giving from the assistant, if the latest message from the assistant is a tool call, then tool condition routes to tool node. So tool node is basically created over here, right? If you create with this other name, this will not happen then. Okay, so that is the reason we have created this tools node. Okay, if the assistant is saying it is not a tool call, then it will go to the end. That basically means this is serve and it will go to the end. So this tool condition basically applies two different conditions. If the latest message from assistant is a tool call, tool condition routes to tool. If the latest message from the assistant is not a tool call, tool condition routes to end. And that is where you are actually doing this with the help of tool condition. Okay, very simple. Here, if this tool calling LLM is making a tool call, it will go to the tool node, otherwise it will go to the end node. That is what tool condition does. Okay, and that is the kind of thing. Whenever there are two edges coming from a node, it has to go inside this additional conditional edges, add conditional edges. Okay, now finally, I will go ahead and add the final edge, builder.add edge, and you know where this add edge should go, right? The final edge will be nothing but it will be from tools to end, right? The other part, sorry, this is a keyword. So other part is that by default, if it is not a tool call, it is anyhow going to go to the end. Okay, so this is actually managing the other condition. Now finally, we will go ahead and compile the graph. After compiling it, let's go ahead and write it out. Graph is equal to builder.compile, right? And then we're going to go ahead and view the graph. Okay, so for viewing the graph, it will be nothing but use that same function called as display. And here we go. State is not defined. Okay, state is not defined. Let me go ahead and again, I think I restarted the kernel, right? So that is the reason we got that issue. So I'm just going and execute this. Okay, this two thing I'll execute it. Perfect. Now this should definitely work. So here you can see that I'm getting one error, node already present. Definitely work. So here you can see that I'm getting one error, node already present. The thing is that I did not define the node definition over here. Okay, so let's go ahead and define this and execute it. Okay, image is not defined because I need to import the image library. It's okay, no worries, I will do that. Okay, now here you can see I've got the same image, start, tool calling LLM, tools, and end. Okay, now it's time we see that how we can probably call this. Okay, quickly. So I'll go ahead and write messages is equal to, or I'll just go ahead and use the same graph dot invoke. So we know there's an invoke method, and here we will go ahead and give our messages parameter, and I'll give my message. Hey, I'll say, hey, what is the recent AI news, right? Now, with respect to this, you know, if I'm executing this, right, it definitely needs to make a tool call to my, to the third-party API with respect to Tably. Now here you can see, this is lovely. See, clearly you're able to see. What is the recent AI news? So here's the human message that has got appended. In the AI message, it did not respond anything. The content is empty. But it is saying that the LLM has made a tool call, right? Tool call. The ID is this, the function name is this, and this is the query, right? With this particular topic news, right? And here you're able to see this. And finally, the tool message that you're getting, recent AI news, follow-up questions, all this information that you're able to see. Okay. Now we need to see what information is able to see, right? So now I will just quickly save this in some kind of response. Okay, response. I'll execute this. Let's go ahead and write this response. So this response is basically coming like this. I will go ahead and see my messages. I will take the last message. It should definitely be a tool call. So tool message. If I just go ahead and write dot content, I should be able to do this. The recent AI news was a query. Follow-up question is null. And this is all the information. NVIDIA self-driving software platform, all this news information is specifically coming. If you want to display it in a much more better way, I can also go ahead and write something like this. For M in, let's say, whatever response I'm getting, response of messages. Okay, response of messages. From this, I'm just going to go ahead and write m dot pretty print. Okay, pretty print. I know. So here you can see what is the recent AI news. It made a tool call of Tably search, and here is my query with respect to all the response that I need to get. Right. Now the question like this, query with respect to all the response that I need to get. Right. Now the question like this, did we go ahead and test some other things? So let's test one more thing. One more tool we added, right? What is 2 multiplied by 3 or the multiply function? What is 2 multiplied by 3, right? And we will try to display the same response over here. This time it will make another tool call, okay? And that tool call will be nothing but it will be a multiply tool call. See, multiply tool call. Now how it is able to do it? Because LLM has that binding information already, right? And it is able to make this specific tool call in a much more easy way. But still, there's one very important thing. See, tool message is coming up something, but the operation is not happening, right? Why it is not happening? See, over here, you can see that what is 2 multiplied by 3, or I'll just go ahead and ask what is 5 multiplied by 2 if I'm executing this, okay? So here you'll be able to see that 5 multiplied by 2, it is not probably producing the right kind of output. So one interesting thing you could see, guys, so over here, when I'm multiplying here, the output is null, right? Then I got to see that there was some mistake that we did. We did not go ahead and write that definition. So return A multiplied by B, okay? So now I'll execute this. This will basically be my tools. Tool LM binding tools. So this will be my LLM tool. Now, let's see. I think now it should get executed. So 5 multiplied by 2. Okay, still I have to go ahead and recompile my graph. Okay, so I'll go ahead and recompile my graph. Now, if I just go ahead and execute it, let's see, it'll come. So now you can see tool call has made 5,2. Argument it is able to find out, and tool message is nothing but name, multiply, and answer. So this kind of issues, smaller issues may come, but you need to go ahead and fix it. Okay. But now one more important thing is that, what if I just go ahead and write something like this? Okay. See this, okay? What is 5 multiplied by 2 and then add 10? Okay. Or let's say I'll go ahead and say then multiply 10. Okay. If I go ahead and execute this, here you'll be able to see some kind of messages. Let's see. So here you can see first what is 2 multiplied by 2 and then multiply by 10. So multiply 5 2, 10 2. Okay. It is able to capture the argument. It is able to find out this multiply, and here also we are able to get it, right? So what is 5 multiplied by 2 and then multiply by 10? It is able to find it out. Okay. Now see, I will again change this. This is also working. Give me the recent AI news and then multiply 5 by 10. Now if I execute this with this kind of query, now just think over it, what is going to happen? So here one very important thing happened, right? Give me the recent AI news. In this particular sentence, there are two important sentences itself. One is the give me the recent AI news and then multiply 5 by 10. With respect to the give me the recent AI news and then multiply, here you can see tably search is done. But after that it gave the output and it came out. But what about this particular query, right? Now what has actually happened? See, if this is my LLM, okay, this is my LLM or this is my chatbot, let's say. Here I asked question, what is the recent AI news? What is the recent AI news? And I asked multiply 5 by 2. Let's say I asked this 2 question. So in a sentence, there are 2 questions, right? LLM, as soon as it got the input, it made a tool call. The tool call was in a tool node. Why did it make a tool call? Because here you can see that it is asking for the recent AI news. And it knows that in the tool call, it has tably API. Okay, tably. And then from here, it went to the end node, right? This was start, this was end. But what about this particular question? Multiply 5 by 2, right? And this is how was my entire graph. Don't you think if we made some kind of changes, then this answer will also be able to come? Now, what was the changes? Here, instead of once the tool node gives you the output, can't we give that output back to an LLM instead of sending this output to the end state? Now, once we make this response back to the LLM, then the LLM will be the main decision maker. And this decision maker will help them to probably take up the next query, multiply 5 by 2. And then it can again make a tool call, because here I have my multiply function also. And then once it gets the response, it will give it back to the LLM and it will combine both the output and give it till the end of the output, give it at the end of the output. So this way of interaction of LLM with tools, right? It specifically uses a very important kind of, that there is a very good communication that happens between LLM and tools. And we use a kind of agent, which is called as a React agent. Okay. And this React agent plays a very important role altogether, right? Now, first of all, what exactly is this React agent? You need to understand. Okay. Let me just go ahead and explain this in a better, simpler example. Here, I definitely have an LLM. Okay. Let's say this is my LLM. I ask a question. Okay. And you know that this LLM is nothing but it is the brain, right? So here, it is the brain, right? When I say brain, this will be responsible in making the decision which tools to call. And in the LLM, I have some kind of binding tools. So here we go ahead and start. Here we go ahead and end, right? And here is my tools node. This is my another node. Okay. So let's say here I give my natural input. The natural input is that provide me the recent AI news. And along with this sentence, I say, hey, multiply 5 by 5. Now LLM, when it takes this specific input, it breaks this into 2 sentences. So first it will try to serve this AI news. As I said, this is the brain, right? So what it does, it knows it has to make a call to the tool node. Now with respect to the tool node, it will get an output, and instead of giving to the end, what it will do, it will come give the response to the LLM. Now the LLM will still have the second sentence context. Then what it will do, it will again make a tool call node. Why? Because this is 5 multiplied by 5, right? So multiply is again there. It will again go ahead and hit this particular tool node and again get the response. Then it will go ahead and see, hey, is there anything left in this particular sentence? Nothing is there. So what it is going to do, it's going to summarize and give you the output at the end. So this way of communication, right? This agent architecture is basically called as the React agent architecture. In React, there are 3 main key terms. One is act, second one is observe, and third one is something called as reason. Act basically means whenever an input comes, the LLM will be able to make a tool call, right? Then when the output of the tool comes, the LLM will observe. Okay? The LLM will observe. Do I again need to make a tool call or should I directly go to the end? Let's say this is a question again coming after that, then again it makes a tool call. Okay? And then again it is going to get the output. Reason basically means after it gets the output, what the LLM should do, that LLM is making a decision, right? And this is where your agent architecture comes into existence. That is where your agent behavior comes into existence. And this was the rise. Because of this, now AgenticAI has become very much popular. Okay? That is the reason why it has become really, really popular. So in order to just implement this, see, I will just give you an example. So here, if I want to go ahead and just use this React agent architecture, okay, how we are basically going to do this? Okay, I will just go ahead and use the same thing. See, I will use the same state graph. This agent, now you should tell me where the changes should happen. Okay, I'll copy this over here. From the tools, instead of going back to the end, it should go back to tool calling LLM. Yes or no? Just think. Instead of going from tools to the end, it is now going to the tool calling LLM. Now, how my diagram will look like? This is how it looks like. From start, tool calling LLM, goes to the tool, and again goes back to the tool calling LLM. And this can keep on repeating unless and until the answer is completely satisfied and the LLM LLM is basically making a decision. Now, if I go ahead and ask this question, now see the magic, okay? See the magic, how good the output will come, okay? So here, if I go ahead and probably just show you the output, give me the recent AI news and then multiply 5 by 10. Now see LLM how it is going to behave. So give me the recent AI news, multiply by this query. The tably search is happening. Perfect. Here's the recent AI news. After this, what has happened? The response has gone back to the LLM. And then now multiply 5 by 10, which is nothing but 5 multiplied by 10, which is 50. And this is how 5 by 10 is query. Now see LLM. Give me the recent AI news and then multiply 5 by 10. Now see LLM how it is going to behave. So give me the recent AI news, multiply by this query, tably search is happening. Perfect. Here's the recent AI news. After this, what has happened? The response has gone back to the LLM. And then now multiply 5 by 10, which is nothing but 5 multiplied by 10, which is 50. And this is how your entire React agent works, right? And I hope you're able to understand this with this beautiful example that I've considered over here, right? And this is with respect to the React agent. So I hope you're able to understand this. Now you can keep on adding any number of tools. The LLM will be the deciding factor which tool to specifically call. So guys, now we're going to go ahead and implement about adding memory in the agentic graph. So whenever you create a graph, LangGraph has a feature wherein you can go ahead and add memory. And this memory actually solves a major problem, that is nothing but persistent checkpointing. Now, why do we specifically use this memory? Okay, so let me just give you some examples. So already if you know that we were able to invoke it from the previous graph that we have actually created. Now let's say that I will go ahead and ask a question. Hello, my name is Krish. Okay, so let's say this is what I'm communicating with my chatbot. So my chatbot should be able to give me a good answer, right? It is going through this entire graph. Over here, the tool call is not required, so directly it is going to the end after giving the answer, right? So let's say that here I've just asked, hello, my name is Krish, and it is able to probably provide a nice response saying, nice to meet you, Krish, how are you today? Now what I will do, I will again go ahead and ask the question, what is my name? Okay, what is my name? What is my name? So now what it is basically going to happen is that, you see, like what kind of response we will be able to get it over here. Now what is my name? It is making this tool call. I apologize for the mistake earlier since the tool ID yielded. I will assume you're asking about your name again. Unfortunately, I don't have any information about your name and it's not provided in the conversation. Can you provide more context or clarity what you mean by name and all? So see, I just now told, hey, my name is Krish, and it also told me that, hey, nice to meet you. How are you today? And now when I'm asking the same question, what is my name? It does not know. So it is not persisting that entire information with respect to the previous conversation or previous interaction that we had. Now, LangGraph has a very special property in order to overcome this advantage, which is called as memory. Now, for memory, what we will do is that we will, let's say that I'm going to use the same graph. Okay, so I will copy this and let's say I go ahead and paste it over here. Okay, with memory, what we will do is that we will, let's say this advantage which is called as memory. Now, for memory has a very special property in order to overcome this advantage which is called as memory. Now, for memory, what we will do is that we will, let's say that I'm going to use the same graph. Okay, so I will copy this and let's say I go ahead and paste it over here. Okay. Now, once I paste it over here, LangGraph has a feature wherein you can create a memory saver checkpoint. Okay. Now, how do I go ahead and create it? So here, what I will do, I will just go ahead and write from LangGraph.checkpointer.memory. Okay. And here we are LangGraph.checkpointer.memory. We're going to go ahead and import. So let's see whether the spelling is correct. Checkpointer.memory. So let me just go ahead and use this. And here you can see from LangGraph.checkpointer.memory, import memory saver. And we go ahead and initialize this memory saver. Now, what this exactly memory saver is? It is nothing but it is an in-memory checkpoint saver. This checkpoint save stores checkpoints in memory using a default dictionary. Okay. So here, if you go ahead and see that, what it is going to do is that with respect to every node that it executes, it is just going to go ahead and save all the information so that you can recall this particular memory again and again whenever it is required based on the previous interaction. Okay. Now, where do we add the specific memory? This is really important. So here we have created a memory object. Where do we add it? While we are compiling, there is a parameter which is called as checkpoint. We have to add this memory. Where do we add the specific memory? This is really important. So here we have created a memory object. Where do we add it? While we are compiling, there is a parameter which is called as checkpoint. We have to add this memory over here, right? So once I go ahead and execute this now you can see that I have this exact right thing. Now what I'll do, I will just go ahead and give some input. Okay. Now see, if I want to use this specific memory, right, for a previous interaction, or probably I want the context of the previous interaction, first of all, we need to go ahead and create a thread ID. This thread ID will be important because it will be related to one specific session. So we will go ahead and create a variable. Let's say I will just go ahead and create a variable. So this is memory, obviously. Okay. And now I will just go ahead and create one config. Okay. Inside this config, we will be using a key, which will be called as configurable. And inside this configurable, we are going to create one thread. And this thread, any ID or any number that I'm giving, it should be unique. Let's say I'm going to probably, a user has joined a session, so I will go ahead and make a thread for that particular user. Okay. And this is the configuration that we need to give, right? Configurable key, and there should be a thread with this particular key value pair, right? And this should be unique. So once I have provided my unique thread ID, now what I'm actually going to do is that I'm going to use this graph and I'm going to call the invoke method. Okay. Now once I call the invoke method here, I'm going to basically give it in the form of keys, right? Dictionary pairs. So here I'm going to basically go and write messages. And now if I give the message saying that, hi, my name is Krish, now see what will be the magic that will happen. Okay. So here, apart from this, right, the messages that we're giving, we also have to make sure that for which thread ID I am providing the configuration. So here there will be one more additional parameter which is called as config, and we will provide this particular config, right? So once we get the response, I will just go ahead and print this response. So this will be graph. Let's go ahead and print it. Okay, response. Perfect. Now I should be able to get my output. So here you can see that output is nothing but this all information is there. Hi, my name is Krish, and it says nice to meet you. All this this information is there, right? Now what I will do, I will quickly go ahead and write response. Or let me do one thing because I think it got appended 2 times. Okay, I'll execute this once again and let's just execute it for one time. Okay, so with this particular thread ID, we'll just execute it for one time. And now here you can see that I'm getting one human message, one AI message. Nice to meet you. Now if I just go ahead and see the last messages, so it'll be messages of -1. So here you can see that if I go ahead and see this particular content, I should be able to see the output. Okay, hi, nice to meet you, Krish. Is there something I can help you with? Okay, now let's go ahead and again use the same config and let me now ask, hey, what is my name? Okay, now let's see whether it will be able to remember or not, because we have already used memory saver and it is putting everything in that memory saver itself, right? So the previous interaction context, it will be able to remember it. Hey, what is my name? Okay, so I'm just going to go ahead and do this, and we're going to print this particular output. Okay, so we are going to print this output, and remember, we're giving the same config. Okay, see, when you create an end-to-end application, this dynamic ID thread ID will be maintained in the session itself. So that way we'll be able to maintain this entirely in the memory saver, right? So here now it is able to understand that, hey, your name is Clash. Okay, so this is really nice, right? Now it is able to remember. Do you know what is my name? Hey, do you remember me? I'll just go ahead and write like this. Remember me, right? This is the beginning of, so I don't have previous memory of you. I have a large language model and all. Okay, do you remember my name? Let's go ahead and ask this question. Do you remember my name? So it will be able to remember me. My name at least. Yes, your name is Krish, right? So it is able to answer that, right? So guys, now we are going to discuss about streaming in LangGraph. See, most of the time, whenever we want to probably invoke or chat with our chatbot, we will basically using this graph.invoke method, right? And somewhere we also use stream, right? Now let's go ahead and try to see like what are the different streaming techniques to probably get the response from chatbot itself when we're executing a graph. So first of all, what I'm actually going to do is that I will go ahead and implement some of the things, like let's say I'll go ahead and initialize my memory saver. Okay. Now inside this memory saver, we're basically just creating a memory object. I will go ahead and create one node definition, and this node is nothing but the name is superbot. And here we are going to use LLM with tool.invoke. Okay, or I can just go ahead and use LLM, right? I'll just create a simple graph to probably show you what are the different types of streaming that is available over here, right? Now let's go ahead and execute this. Now here is my entire chatbot node that is available over here, right? Now I will just go ahead and create my entire graph. So let's say this is a very simple graph wherein I am trying to create a node called a superbot. The functionality is nothing but superbot. Here from start to superbot, superbot to end, and then we are compiling it with a checkpointer. Memory, right? And this is how my graph looks like. Very simple graph. I think we're learning a lot, right? Out over here from that much time. In this entire session, we have understood how to create different types of graph. what to end called as this is a very simple graph wherein I am trying to create a node called a superbot. The functionality is nothing but superbot. Here from start to superbot to end, and then we are compiling it with a checkpointer memory, right? And this is how my graph looks like. Very simple graph. I think we are learning a lot, right? Out over here from that much time. In this entire session, we have understood how to create different types of graph. Now what I will do, I will go ahead and create a thread. Let's say the thread is one. I'll say, hey, my name is Krish and I like cricket, and I will give this particular config, and I'm just going to go ahead and invoke it. Okay. Now when we are invoking it, you can see there are some information that you are seeing, right? One is human message, one is the AI message. AI message is basically the response. Now with respect to this, we are going to learn about some streaming techniques. Okay, and this will be very, very handful when you try to develop some kind of chatbot. Okay. So inside the streaming, you have dot stream method and stream method. This method is sync and async method for streaming back results. And inside the stream and stream method, you have these two parameters. One is value, okay, and one is nothing but updates. Now the question rises, what exactly is the difference between values and updates? So in order to make you understand, let me go back over here. Okay, let's say I have a, and this is related to streaming, right? So in order to make you understand what is the differences between value and updates, that is what we are going to discuss. Okay, so let's say this is my streaming, right? Streaming topic. So first of all, let's say I have this graph. Inside this graph, I have various nodes. Let's say I have node 1, I have node 1, I have node 2 that gets executed, and then finally I have node 3. And the flow of execution is in this direction, right? And we are discussing about stream and stream methods. There is a stream method, then there is an stream method. In order to understand the difference between stream and stream, this is like specifically used for async. Okay. Now, if you know Python, I think you should get an idea about what sync and async basically means, right? But the main important point that I'm really interested in is understanding about modes. So inside this method, you have two modes. One is update mode, and one is value mode. Okay. One is value mode. Okay. Now, what is the difference between update mode and value mode? And we will play with this parameter. Okay. This is an additional parameter we give. Let's say over here in node 1, as soon as the node 1 gets executed, here my messages variable will be equal to, let's say, hi. Let's say my LLM gives a hi message when node 1 is executed. When node 2 is executed, the messages will probably have another information like my name is. Okay. So this will be my another information. And when node 3 executes it, my current message that is getting updated, okay, is nothing but Krish. So this is a very simple thing. When node 1 gets executed, my current output response is hi. Then node 2 gets executed, my current response is my name is. And when node 3 is getting executed, it is nothing but Krish. Okay. Now, if I use mode is equal to update, only the message that is currently getting updated, only that message will get displayed as an output. Okay. Let's say if node 1 is getting executed, if I just go ahead and print or do the streaming with respect to mode is equal to update, only this message will get updated, right? Let's say after executing all these 3 nodes, this is the message that is getting executed. Again, I go ahead and give my another input. Then this message will get generated. Then this message will get generated. Whereas in the case of values, in the first case, I will get a message as hi. Okay. But when again I give the message, this message is equal to hi will also get appended, and it will come as my name is in the form of list, right? So this is basically getting appended over here, right? When I try to stream with the help of mode is equal to value. Similarly, when I go to again I give an input and execute all the specific nodes, then here you'll be able to see that I'll get another message which will say, hi, my name is Krish, right? So this is how it gets executed, right? Here, in a specific execution, what is one of the messages that gets appended or that gets displayed, that only I will be able to see it. Okay, so that is a basic difference between mode is equal to update and value. But if you still have confusion, we'll try to understand this with an example over here, okay? So now what I'm actually going to specifically do is that, now you can see over here that I have this, okay? My name is this and all. So here I'm going to basically go into messages, and now if I give a message saying, hi, my name is Krish, see what will be the magic that will happen. Okay. So here, apart from this, right, the messages that we're giving, we also have to make sure that for which thread ID I am providing the configuration. So here there will be one more additional parameter which is called as config, and we will provide this particular config, right? So once we get the response, I will just go ahead and print this response. So this will be graph. Let's go ahead and print it. Okay, response. Perfect. Now I should be able to get my output. So here you can see that output is nothing but this all information is there. Hi, my name is Krish, and it says nice to meet you. All this information is there, right? Now what I will do, I will quickly go ahead and write response. Let me do one thing because I think it got appended 2 times. Okay, I'll execute this once again, and let's just execute it for one time. Okay, so with this particular thread ID, we'll just execute it for one time. And now here you can see that I'm getting one human message, one AI message. Nice to meet you. Now if I just go ahead and see the last messages, so it'll be messages of -1. So here you can see that if I go ahead and see this particular content, I should be able to see the output. Okay, hi, nice to meet you, Krish. Is there something I can help you with? Okay, now let's go ahead and again use the same config, and let me now ask, hey, what is my name? Okay, now let's see whether it will be able to remember or not, because we have already used memory saver and it is putting everything in that memory saver itself, right? So the previous interaction context, it will be able to remember it. Hey, what is my name? Okay, so I'm just going to go ahead and do this node called as superbot. The function is value mode. Okay, now what is the difference between you have these two parameters? One is value. Okay, what exactly is the difference between values and updates? So in order to make you understand, let me go back over here. Okay, let's say I have a, and this is related to streaming, right? So in order to make you understand what is the differences between value and updates, that is what we are going to discuss. Okay, so let's say this is my streaming, right? Streaming topic. So first of all, let's say I have this graph. Inside this graph, I have various nodes. Let's say I have node 1, I have node 1, I have node 2 that gets executed, and then finally I have node 3. And the flow of execution is in this direction, right? And we are discussing about stream and stream methods. There is a stream method, then there is an stream method. In order to understand the difference between stream and stream, this is like specifically used for async, okay? Now, if you know Python, I think you should get an idea about what sync and async basically means, right? But the main important point that I'm really interested in is understanding about modes. So inside this method, you have two modes. One is update mode and one is value mode, okay? Value mode. Okay. Now, what is the difference between update mode and value mode? And we will play with this parameter. Okay. This is an additional parameter we give. Let's say over here in node 1, as soon as the node 1 gets executed, here my messages variable will be equal to, let's say, hi. Let's say my LLM gives a hi message when node 1 is executed. When node 2 is executed, the messages will probably have another information like my name is. Okay. So this will be my another information. And when node 3 executes it, my current message that is being getting updated, okay, is nothing but Krish. So this is a very simple thing. When node 1 gets executed, my current output response is high. Then node 2 gets executed, my current response is my name is. And when node 3 is getting executed, it is nothing but Krish. Okay. Now, if I use mode is equal to update, only the message that is currently getting updated, only that message will get displayed as an output. Okay. Let's say if node 1 is getting executed, if I just go ahead and print or do the streaming with respect to mode is equal to update, only this message will get updated, right? Let's say after executing all these 3 nodes, this is the message that is getting executed. Again, I go ahead and give my another input. Then this message will get generated. Whereas in the case of values, in the first case, I will get a message as high. Okay. But when again I give the message, this message is equal to high will also get appended, and it will come as my name is in the form of list, right? So this is basically getting appended over here, right? When I try to stream with the help of mode is equal to value. Similarly, when I go to again I give an input and execute all the specific nodes, then here you'll be able to see that I'll get another message which will say, hi, my name is Krish, right? So this is how it gets executed, right? Here, in a specific execution, what is one of the messages that gets appended or that gets displayed, that only I will be able to see it. Okay, so that is a basic difference between mode is equal to update and value. But if you still have confusion, we'll try to understand this with an example over here. Okay, so now what I'm actually going to specifically do is that now you can see over here that I have this. Okay, my name is this and all. Okay, now what I will do, I will use the stream or stream method, whichever method you specifically want. We can use this. Okay, so let's say that I go ahead and create a thread, and this particular thread has for chunk in graph builder dot stream, and I'm giving this message. My name is Krish. I like cricket. I've given this particular config, that is nothing but with thread. And this time I've used stream mode is equal to updates. Okay, so there are two stream mode. One is updates and one is values. Now with respect to updates, if I just go ahead and print it, okay, now see what will be the output that I'll get. Okay. So it shows that two stream.
हेलो हेलो कल रहा था कैसा रहा मतलब एकदम जो पढ़ी थी उसमें से आया कि कुछ और आ गया सब लोग आ गए फिर तो स्मार्ट है फ्रेंड चुप करा फिर सबसे पहले ही होगी अच्छा सेंसस पे लेके जाती है अच्छा वो तो वो लेके जाती होगी तेरा वो ऑरेंज 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 ग्रीन बोर्ड के पेपर नहीं है भाई कि ट्रांसपेरेंट लेके जाना पड़ेगा हाँ बढ़िया बोर्ड वाला एकदम स्कूल के हिसाब से बिल्कुल खुला लेके नहीं जाना है चलो तो ही जाएगा ठीक है चलिए ठीक है बच्ची तो है ही हाँ बता क्या नींद में मतलब नींद में लग रहा हूँ तो तेरे से बात किया उसके बाद मैंने मुंह ही नहीं खोला है मतलब मुंह से किसी से बात नहीं किया बीच में उठा दलिया खाया नारियल पानी पिया उसके बाद वापस बैठा ही हूँ क्या अरे पापा कल लाए थे लेकिन फिर पापा बोले क्या तो खाने का टाइम
Updates and on these values. Now with respect to updates, if I just go ahead and print it, okay, now see what will be the output that I'll get. Okay, so it shows that what is the current execution AI message, that is what I'm actually getting. I did not get the human message. See, focus in this. Whichever was the last message which came from the AI, only that is getting displayed. But if I just go ahead and execute the same thing, instead of writing mode is equal to updates, I'll go ahead and write mode is equal to values. If I execute it, here you can see human message. Here also you can see 2 times human message has got appended. And if you go forward, your AI message will also get appended over here. See, AI message, right? So all the conversation is basically getting updated, right? When you whether you give an input, whatever output you get here, specifically output you're getting. Okay, here specifically output you're actually getting, right? Again, let me repeat this. Over here, you'll be able to see that whatever output you get after any node, and if you try to stream it, only that is basically getting displayed. This is the AI message over here. Whereas in the case of mode is equal to value, everything is getting displayed. Your human message, your AI message, everything is getting displayed. So that is the basic difference between these modes and values. Okay, so now I hope you get this clear understanding. Okay, and let's say that I go ahead and add one more message. Okay, I'll say, hey, see, I executed this 2 times, right? This is the first time. This is my human message, and here also I got a AI message, and everything is basically getting updated. Let's say I go ahead and add one more method, or I just go ahead and create one new key. Okay. Okay, so let's create this, okay, and you'll be able to understand this very clearly. So here I will just go ahead and use thread is equal to 4. Okay, I'll say hi, my name is Krish. I like cricket. Let's start from fresh. So here now mode is equal to update. Now I'll be getting the AI message over here, obviously, since I've used this. So I've got the AI message. Now again I will go ahead and use another message over here, and I'll say I also like football. Okay. Now see, what will happen if I make this updates to values? Okay. Now see, if I go ahead and print the chart, I'm getting a human message. My name is Krish. I like cricket. So this is saved in the memory. My next prompt will be something related to I also like football. You can see this. Okay. So let this get printed. It's still executing. So right now I got this human message. In the next sentence, the previous conversation has also got attached. Right? Previous conversation has also got attached. And then probably after some time when this gets executed, you'll be able to see that one more message will get appended, and that is related to human message. See, my name is Krish. I like cricket. The previous one. Along with that, hi Krish, nice to meet you. So you also like cricket. Which team do you support? He's asked the question. And if you go forward, here you can see AI message. A sport fan with diverse effect. Now see, here somewhere human message. I also like football has got added, and here you got the response. So values, what it is doing is that it is keep on adding all the conversation inside this, and you're able to stream through that entire information. Sometimes this becomes very good in use cases where you are focused on understanding about things and all that. And if you want some more detailed information and all. Now there is one more method which is called as a stream methods. Okay, and for this you just need to probably go ahead and use like this. See, I'm using another thread ID. Let's say thread ID will be 5. Here.
हाँ बोल क्या बोले मैं तो कॉलेज में अभी तो कहीं भेज सकती है अच्छा तो अभी अकेले गई थी मैंने तो निशा वगैरह के साथ गई दूसरा में तो देख ठीक है एक कैबिनेट इतना अच्छा मुझे लगा इतना बड़ा एक नहाने का भी है तो अच्छा अच्छा ये इंडियन स्टाइल वाले में जाओ बैठो कर लो है कौन सा कौन क्या वापस बता दो क्या कहा था तुम्हें ओह अच्छा तो इतने बात करने लगे वापस तो क्या लेना अच्छा और बताओ अरे वही मशीन लर्निंग वाला पढ़ा मिल गई? हैं? नाइस, अच्छी बात है, अच्छी बात है। क्या हुआ? किस पे? एक काम ढंग से नहीं हो सकता तुझे? इधर उधर गिरते रहो, कभी ये कभी वो। क्या हुआ, नहीं आई? हाँ? हाँ। और मैंने कोर्स कर लिया रजिस्टर। कहाँ? अच्छा, और इसने कर लिया? उसको भी तूने सारा भेज दिया था क्या? तो फिर नहीं हुआ उसका? हाँ। है, तेरा दिमाग है, स्मार्ट है तू। तो मेरे साथ रहने से कुछ तो दिमाग आ रहा है तुम्हारा। नाइस। हम्म, ये खांसी कैसे हो गया तेरे को? ये खांसी कैसे हो गया तेरे को? डिस्को डिस्को कर रही थी। और मत खाओ खाना, इम्यूनिटी कमज़ोर हो गई। अच्छा। हाँ, बता देना आज। हम्म, अरे मैंने तेरा वाला फोल्डर हाइड ही नहीं कर रखा है फिर फिर एक गूगल फोटोज में हटता ही नहीं है, पता नहीं इसके अंदर कैसे रह जाता है सब। मैं फ़ोन में से हटा देता हूँ फिर भी इसके अंदर पड़ा रहता है, पता नहीं क्या है इसको लेकर। ज़बरदस्ती ये कोलाज बना देता है, तेरे सारे फोटो कोलाज ही बना देता है। मैं मेहनत करूँगा क्या? बिना मेहनत के तू सेट है। वाई टू डू अननेसेसरी? क्यों नहीं है? फिर नहीं लगता मैं मेहनत करता हूँ फिर। मैं ये सुनना चाह रहा था कि तू बोल दे कि हाँ अरे करते तो हो, लेकिन नहीं, लेक्चर ही शुरू हो गया मेरा तो। हम्म, 4 वीडियो दिए? हाँ, अच्छा, ये सही है। हाँ, खुद के लिए भी अप्लाई करो थोड़ा है। तो ये क्या होती है, एक्सेप्शन कैसे आ गई? सेम सेम वी आर इक्वल। क्यों? क्यों नहीं हो? क्या बोलती, मैं खुद ही कंफ्यूज हो गया, इतना कुछ बोल दी ये भयंकर गूगल फोटोज। ठीक है, इसमें नहीं है, पता नहीं कंफ्यूज होगा शायद, ना ना। और बताओ फिर। और कुछ नहीं। तेरे बगल में कौन बैठा है? हाँ, कोई नहीं, कंच कलर ठीक है फिर। वो तो तेरे को आता है, वो तो बिल्कुल पढ़ती पास है। तेरे को तो आता है ना, पर मैथ तो तू ऐसे बोलती है मैं थूक दूँ तो पास कर जाऊँगी। तूने बोला था। तूने बोला था कि मैं बिना पढ़े भी टॉप कर जाती थी मैथ्स में। थोड़ा थोड़ा सा पढ़ के आता हूँ। इसको नहीं पढ़ लेना। मैंने इंटीग्रेशन में 12th में करी थी ना। जब 11th 12th में नहीं करी तो बीटेक में से क्या ही करवा लेता। बैठना है? हाँ, बैक नहीं आएगी। मेरी नहीं आई तो तेरी कैसे आएगी? वाह वाह वाह, मेरी मैथ और अच्छी, दोनों दोनों शब्द एक सेंटेंस में अच्छे नहीं लिखे। ट्विटर पे एक बंदे ने ट्वीट किया है कि अपने दूसरे बच्चे का नाम प्रथम प्रथम कौन रखता है? अपने दूसरे बच्चे का नाम प्रथम कौन रखता है? अरे किसी ने डाला है, समझी मतलब? अरे अपने दूसरे बच्चे का नाम प्रथम कौन रखता है? प्रथम मतलब क्या हुआ, फर्स्ट हुआ, पर बच्चा तो सेकंड है। तो एक ने सुन ले, एक ने कमेंट किया है जो पहले वाले से परेशान हो, पहला वाला ट्रायल बोलता। हो सकता है पहले बच्चे का नाम शून्य रखा हो।